Hi girls, today we are going to see about electromagnetic waves. The electromagnetic waves are non-mechanical waves. Non-mechanical waves means they do not need any material medium for propagation and which move with a speed equals to the speed of light in vacuum, and it is also a transverse wave. And we are going to see about the production and properties of electromagnetic waves. And here first, the electromagnetic waves are produced by Hertz. So even though Maxwell predicted there are some waves called electromagnetic waves, Hertz is the first scientist who produced electromagnetic waves in the laboratory. So here when you see how it is produced, the experimental setup, and here when you see the small balls will be there and they act as electrodes, and these small balls are connected, the other end is connected with the induction coil where a high voltage is given as input, and here the larger balls they act as a transmitter and it transmits the electromagnetic waves. And so here this part is called a receiver, and this transmitter will produce electromagnetic waves and the receiver will receive the electromagnetic waves. When you see, when the input is given, the air gap between the two balls here, that is plus q and minus q, the air gap gets ionized, and so there will be an oscillating electric charges produced. This oscillating charge is nothing but electromagnetic waves, which is the source of electromagnetic waves, and a spark is created here. This spark is received by this receiver, which is at some distance away from the transmitter. So here the electromagnetic waves are produced and then they are received by the receiver. And so when you see the experimental setup, it consists of two metal electrodes which are made up of small spherical metals, and they are connected with the larger spheres, and then they are connected to the induction coil which have large number of turns. And here the air between the electrodes gets ionized and the spark is produced. This spark is nothing but the discharge of electricity. So here the energy is transmitted from the electrode to the receiver, and this receiver is otherwise called as a ring electrode because this is in the form of a ring. And so here the electromagnetic waves are produced. These waves are known as electromagnetic waves, and when you rotate the receiver by 90 degree, there will be no spark, which shows that the electromagnetic waves are transverse in nature. And here when you see, Hertz detected these radio waves and they are found to be have the speed which is equal to the speed of light 3 into 10 power 8 ms power minus 1. And next we are going to see about properties of electromagnetic waves. There are 8 properties in this. So first one is they are produced by an accelerated charge, and the stationary charge cannot produce the electromagnetic waves. Only the accelerated charge can produce electromagnetic waves. And here, as I have said previously, they do not require any material medium for propagation, and they are also non-mechanical wave. Mechanical wave, you can have the example, you can take sound and water waves, they are mechanical waves. And electromagnetic waves are transverse in nature. And when you see the electric field, magnetic field and the direction of propagation, all they are mutually perpendicular to each other. This diagram shows that the electric field and magnetic field is along z and y direction, and the direction of propagation is along x. So the red region shows the electric field and the blue region shows the magnetic field. They combinedly move in the direction of x, which is the direction of propagation. And so here they travel with the velocity of light, which is given by the formula c is equal to 1 by square root of epsilon naught mu naught, and where epsilon naught you know permittivity of free space and mu naught is permeability of free space. When you calculate the value is about 3 into 10 power 8 ms power minus 1. Suppose if we take a medium, and the medium the permittivity becomes epsilon and the permeability becomes mu. In such a case, V is less than C, and so here N you know refractive index of the medium, which is given by C by V. C you know 1 by square root of epsilon naught mu naught, and V is 1 by square root of epsilon mu, and when you cancel, N is equal to square root of epsilon naught mu r, where epsilon r mu r is relative permittivity and relative permeability, and this relation you already know. that is epsilon by epsilon naught is equal to epsilon naught, and similarly mu by mu naught is nothing but mu r. And here electromagnetic waves are not deflected by electric or magnetic field because they are chargeless, so they are not deflected. And electromagnetic waves exhibit the three main phenomena: interference, diffraction and polarization. Interference is nothing but overlapping of two waves, and diffraction means the bending of waves around the obstacles, and polarization means the vibrations are restricted to a single plane. These three phenomena we shall see later. And here electromagnetic waves have energy, linear momentum and angular momentum. And you know about momentum. Momentum is nothing but product of mass and velocity, and linear momentum refers the momentum in the straight line, and angular momentum refers the momentum in angular path, that is in circular path. So these are the main important properties of electromagnetic waves. Next we are going to see about the sources of electromagnetic waves. So when you see a stationary charge, that is a fixed charge, it produces only electric field, whereas if the charge moves, it gives rise to magnetic field. This magnetic field is not time dependent, and it is only space dependent. And so here when the magnetic field moves, then it also produces an electric field in addition to magnetic field. And these electromagnetic waves are, already you know, they are transverse waves, and the direction of propagation of electromagnetic waves is perpendicular to the planes containing electric and magnetic field vectors. So the oscillatory motion, otherwise it is called as accelerated motion, this oscillated motion of charges will produce electromagnetic waves. And here when you see this diagram, and here in this diagram, discharging spark or oscillating molecular dipole in the between two balls. You see there are two balls, and these two balls will produce an spark, and this spark is nothing but electromagnetic wave, and the electric field is in this direction, which is shown by red line, and the blue line represent the magnetic field vector. So this electric field vectors and magnetic field vectors, they are perpendicular to each other, and they combinedly they move in the direction along the direction of propagation. And so here Z is the propagation of electromagnetic waves. So X is the direction of electric field, Y is the direction of magnetic field, and Z is the direction of propagation. And so the direction of E is I cap, and the direction of B is along J cap, whereas the direction of G is along K cap. And here the equation is Ex, because E is along X direction, so Ex is equal to E naught sin kz minus omega t, and By because along y direction, so By is equal to B naught sin kz minus omega t. Here you know E naught and B naught are the amplitudes of oscillating electric and magnetic field, and K is the wave number, and you know K is given by the equation 2 pi by lambda, where lambda is the wavelength. So usually wave number is nothing but reciprocal of wavelength, and omega is angular frequency. And here when you see I cap cross J cap, you will get K cap. So this K cap is nothing but the direction of the electromagnetic wave. So they are, all the three are mutually perpendicular to each other. So the oscillating charge is a source for the production of electromagnetic waves in space or vacuum. And here you already know this equation. C is the velocity of light, which is given by E naught by mu naught. Suppose if we take any medium, then the velocity is E naught by B naught, which is less than C. So surely the velocity is less than the velocity in air or vacuum. And next we are going to see about electromagnetic spectrum. In this, when you see this diagram, you are having 7 types of waves from left to right: radio, microwave, infrared, visible light, UV, X-ray and gamma rays. And here when you see the wavelength is going on decreasing, whereas the frequency is going on increasing. So the frequency is in ascending order, whereas the wavelength is in descending order. Here among the 7 waves we can see only visible light, and other waves are not visible to our eyes. And first we are going to see about What is electromagnetic spectrum? It is an orderly distribution of electromagnetic waves in terms of wavelength or frequency. So we are arranging according to their wavelength or frequency. And when you first see the radio waves, these radio waves are produced by accelerated motion of charges in conducting wires, and frequency range is few hertz to 10 power 9 hertz, and they show the phenomenon of reflection and diffraction. And on all communication systems like radio, television and cellular phones, for voice communication, even for these classes we are using this radio waves, and it is used in ultra high frequency band. Then microwaves are produced by vacuum tubes, and these vacuum tubes you can study in higher classes: klystron, magnetron and gun diode. And the frequency range is 10 power 9 hertz to 10 power 11 hertz, and they undergo reflection and can be polarized. And these are mainly used in radar system, speed of the vehicle, microwave oven for cooking, and for very long distance wireless communication. So the both radio waves and microwaves alone can be used for communication purpose. Other waves cannot be used for communication. Mainly these two waves are responsible for communication. And infrared radiation are nothing but heat waves. They are otherwise known as heat waves. The frequency range is 10 power 11 hertz to 4 into 10 power 14 hertz. They are used in satellites by means of solar cells, because the solar cells get the energy from sun and convert it into electrical energy. So heat energy is converted into electrical energy. So the satellites can continuously derive energy from these solar cells. And ultraviolet rays, infrared rays can be used for dehydration in fruits and greenhouses to keep the plants warm, and heat therapy for muscular pain or sprain, because infrared rays are heat waves, so it can be used for heat therapy. And in TV remote, and it is also used to take photos in near even through the haze, fog or mist, because it can penetrate through the fog or mist and it can take the photography easily. So infrared photography can be used in night vision. So next, visible light. So everything in the world is visible to our eyes because of this light, and they are produced by incandescent bodies. That means when they heated up to very high temperature, you can get visible light. They are radiated by excited atoms in gases, and the frequency range is 4 into 10 power 14 hertz to 8 into 10 power 14 hertz, and throughout this the frequency is going on increasing. And here the obey laws of reflection, refraction, it undergoes interference, diffraction, can be polarized. Also the main phenomenon of light is photoelectric effect. Photoelectric effect means the production of electrons by the light. That is called photoelectric effect, because when light falls on certain substances it produces electrons. This effect you can study in the later chapters, and it is used to study the structure of molecules, arrangement of electrons in external shells of atoms, and it causes sensation of vision. Next, ultraviolet radiation. The main source is sun, arc and ionized gases, and even from the TV and tube light you are having mild amount of ultraviolet radiation. The frequency is about 10 power 15 hertz to 10 power 17 hertz, and here so when you see, it has less penetrating power, and it is absorbed by atmospheric ozone, or otherwise it will reach to our body and it will cause some harmful effect. And it can be also used for sterilizing the surgical instruments, burglar alarm, to detect invisible writing, fingerprints, and also in the study of atomic structure. Even the forgeries can be identified with the help of these ultraviolet rays. Next, X-rays. X-rays are produced when there is sudden stopping of high speed electrons at a high atomic number target. For example, you can use tungsten, which is having high atomic number. When the electrons are suddenly stopped by this tungsten, there will be electronic transitions among the innermost orbits of atoms, and they produce X-rays. The frequency range is 10 power 17 hertz to 10 power 19 hertz, and they have more penetrating power than ultraviolet radiation. That's why it is used for detecting the fractures, and they are used in studying structures of inner atomic electron shells and crystal structures. And already we have seen the uses of X-rays. They are used for detecting fractures and diseased organs, formation of bones and stones. And they can be also used for the other treatments for healing bones, etc. And in finished metal product, for example for gas cylinders, etc., which is used in our house, it is used to detect any fault, crack or flaws and holes during the manufacturing time. And when you take gamma rays are produced mainly by transitions of radioactive nuclei and decay of certain elementary particles. And when some elementary particles they decay, they will produce gamma rays. They have high penetrating power, and usually they will affect the photographic plate, and they produce fluorescence, ionization and diffraction. And ionization, you know the phenomenon, and the frequency range is 10 power 18 hertz and above. So gamma rays are having very high penetrating power, and it is very harmful to our body, and they provide information about the structure of atomic nuclei, and it is also used in medical field for the treatment of cancer and tumor, in food industry to kill pathogenic microorganism. That is it is used to preserve foods. Gamma rays can be used for preserving the food. That's all girls, hope you understand.